substance that has mass and occupies space is called matter. It is made up of small particles called atoms that cannot be further divided. That atom is the ultimate particle of matter. This theory is called Dalton's atomic theory. It postulates that all matter is composed of atoms that cannot be made or destroyed. All atoms of the same element are identical. Different elements have different types of atoms. Chemical reactions occur when atoms are rearranged. Compounds are formed from atoms of the constituent elements. Dalton's atomic theory was able to explain the laws of conservation of mass, multiple proportion, and constant composition. However, it could not explain the results of many experiments conducted by the scientists in the later part of the 19th century and 20th century. For example, it could not explain the electric nature of matter as explained by Michael Faraday through his experiment in 1830, them in 1909, in order to calculate the charge of an electron, and used it to calculate their mass. He then ionized the air inside the condenser by passing a beam of X-rays through it. The X-rays displaced electrons from air molecules, which negatively charged the oil droplets. On applying voltage to the upper positive plate, the charged oil droplets got attracted towards it against all gravitational and electrostatic forces. Millikan then varied the voltage Q on the droplets is always an integral multiple of the electrical charge E. That is, Q is equal to NE. Knowing the values of Q and N, Millikan calculated the charge on an electron to be 1.6 into 10 raised to the power minus 19 coulombs. The mass of the electron, or ME, was then determined by combining the results of Millikan oil drop experiment and Thomson's value of E by M ratio, and was found to be 9.1094 into 10 raised to the power minus 31 kgs. Just like the discovery of cathode rays led to the discovery of the negative dose originating from hydrogen gas. Therefore, the positive particles from hydrogen gas carrying charge and mass of negative and positive subatomic particles, scientists tried calculating the atomic mass. It was determined that the atomic number of an element is equal to the number of protons present in its nucleus. It was thought that since each proton has one unit mass on the atomic scale, the mass of an atom must be the number of protons present in the nucleus, as electrons have negligible mass. However, it was discovered that the mass of all protons, that the excess mass was due to some other particles present in an atom that had considerable mass but no charge. Later in 1932, James Chadwick proved the presence of these heavy, neutral particles through a series of scattering experiments. In one of his experiments, on bombarding a beryllium plate with alpha particles of a proton, he named this particle as neutron. After all the subatomic particles were discovered, it was concluded that an atom is made up of protons or positively charged particles, electrons or negatively charged particles, and neutrons that are neutral particles. The table here summarizes the properties of these fundamental particles.